Good afternoon, I am Mr. Ish. Thank you for joining me for this chemistry video where we are looking at a very beneficial and important concept. The question is this: a student claims to generate 5 grams of precipitate when reacting 5 grams of silver nitrate. Silver nitrate is normally available as a solution, but it could also be available in a powder form. Assume that you can find this in terms of a powder form. With 10 ml of 3 molar carbonic acid, is this possible? Is the claim possible? Can silver nitrate in terms of its moles and carbonic acid in terms of its moles combine to generate 5 grams of precipitate? We have to determine that to be true or false. What's the reaction? The reaction is silver nitrate, AgNO3. It's combining with carbonic acid, H2CO3, to generate a certain precipitate, which will be this silver carbonate, Ag2CO3, and then you'll have a nitric acid form, HNO3. You have to balance it, and it would be this. Generally, we all know all of these would exist to a certain degree as spectator ions. This would really be Ag plus, and you'll have a nitrate, and then all of that. This right here would be 2H plus, and then you have a carbonate. Based on how they dissociate, how easily it dissociates, here you'd have 2 silver ions, and here you'll have carbonate. Based on its solubility, product equilibrium, can it fully dissociate or not? All of these are considerations to be made, but we're worrying about here only with regards to this reaction. We're assuming the spectator ions don't come out and they don't start interfering with regards to an incomplete reaction. We assume everything here is a complete reaction. Assuming that, let's answer this question. So I'm going to erase this. But this is a consideration which should always be in the back of our minds. We have to determine basically what is the limiting reagent for both of these. And we will do that. We have AgNO3, and then we have carbonic acid. For this, we have 5 grams of this, dividing by the molecular weight of this, and we can do that. Silver is 107.8 plus 14 plus 48. We have 169.8 grams per mole. Carbonic acid, we have 10 ml, which you know you have to do molarity is equal to moles over volume. You can multiply the volume across, but volume here is in liters. It should be in liters. It would be 3 molars times 10 milliliters divided by 1000 ml per 1 liter, and you'll get your moles over here. You'll basically have 10 divided by 1000 times 3, you'll get 0.03 moles. Now we have to determine this. Which one is smaller? Whichever one is smaller is your limiting reagent. This is 0.02945 moles. Because we've determined the silver nitrate to be the limiting reagent, I can erase this. Now let's determine the precipitate. We have this in terms of its moles. We have 0.02945 moles of silver nitrate. And remember, what we have here is like a double displacement reaction. 2 species are displacing a portion of the other, and you have a double displacement reaction, times you have 1 mole of this precipitate, Ag2CO3 silver carbonate, per 2 moles of AgNO3. Multiply this by now the molecular weight of this. You're going to have, what's the molecular weight of silver carbonate? We have to determine that. It'll be 107.8 times 2 plus 12 plus 48. We have times 275.6 grams per mole of Ag2CO3. Now look, the moles silver nitrate with this will cancel out. The moles that will cancel out with this. The only thing which will remain are your grams of your precipitate that you're looking for. You have to do this times that, and we'll do it. We'll do 0.02945 divided by 2, because I have a times 1 or 2, and then we'll multiply by 275.6. And what we're getting here is 4.05, which I'll round up to 4.06 grams of precipitate, which I'll just write as precipitate. This right here represents our theoretical yield. This is the maximum you could have obtained. The actual may be certainly less than that, because no reactions go through to 100% completion, and there's always contamination, and that prevents our reaction from being 100% in terms of its yield. This right here is my theoretical yield. The theoretical yield is 4.06 grams. That's a maximum you can obtain given the reactants and their amounts that are provided. The student claimed to have generated 5 grams of precipitate, so that's not possible. Is that possible? No, it isn't, and your question will have been solved. It's not possible to generate 5 grams, but it is certainly possible to generate up to 4.06, though the likely actual yield will be less than 4.06. And that right there would be our answer, the short answer here being no. And that's exactly how you do a question like this. Again, remember we have this reacting with this in a double displacement reaction to generate this precipitate. And everything would normally dissociate in the presence of the solution in the solvent that it's present in, and you'd have spectator ions come into play, and some things would actually dissociate. This would actually dissociate based on its KSP, solubility product constant, into something which would be really Ag and then carbonate. All of that would have to be factored in down the road as you get a little bit more comfortable in chemistry with regards to this, because the precipitate might not actually be even 4.06, because this may have a certain tendency to dissociate into this, and it would eliminate, or it would lessen the amount of actual precipitate you're getting to something smaller than what you're calculating. But that's all I want to present to you in this video. Thank you for watching. Have a good day.